In this video, I'm going to show you how to use the Bluetooth extension board together with the Nucleo board. Okay, so this board, its part number is called the X-Nucleo-IDB05A1. I'm going to interface to my Nucleo board, and together I'm going to use the sensor board as well, so that I'm going to show you an example of how to send the temperature values from the sensor board to the handphone application via the Bluetooth PLE. So I'm going to attach the sensor board to the Nucleo board via the Arduino connector, and then I will stack the BLE board on top of the sensor board, and I'll connect the USB. So first step, I'm going to open the STM32 So as usual, my board is a Nucleo 64 L053R8. Double click on this and initialize all peripherals with the default. Since the high-speed crystal are not used, I'll change these two pins to the reset. So first I'm going to configure the pins for the sensor board, which is using the DB9 for the I2C pin. Under connectivity, I'll select the I2C channel 1 and enable. Everything will be set to standard 100 kHz and primary address of a 7-bit length. Okay, next I will set the connection for the PLE Bluetooth board, and but first we need to download the software packs from the internet. So I have to go to the software package manager. Under the ST Microelectronics tab, select the BLE1 and the BLE stack and sample application for the blue NRG MS module, and click install. After I've installed, click on the package software packs again, select the components. So we got to use both the MEMS MEMS. So I'll select the board extension. Okay, if you have forgotten, this is the first video that you have watched for my channel, you can refer to another video which I show you how to use the sensor board. And for this board is execute BLE. Select the wireless blue NRG MS. Click on the controller and the utilities, and the HCL TL select basic, and the interface select the user board. You can refer to the documentation from the internet for more information. Yeah, Stm32 configuration steps. So we'll show you step by step how to configure, including the ports and the pins that we need to configure for the QMX. it's very detailed, so you can just refer to this document. Okay, click OK, and then we'll set the rest of the pins. As usual, the clock normally I'll set to 16 megahertz. According to the datasheet for Stm32 L053R8, the maximum SPI speed will be 8 megabits per second. So we select 16 prescaler. So 16 megahertz divided by 16, we get 1 megahertz. Okay, next we have to enable both. Okay, let's enable the sensor board first. So this we have to select the I2C one and the wireless blue NRG-MS. Yeah, I forgot something. So we gotta go back to the software packs, select the component, and yeah, we have to select the application as well. So for this case, I'm going to use the sensor BLE. So have to select the device BLE application, and everything will appear. So I just follow the documentation from the ST Microelectronics. Okay, for the UART, we're going to use the USART instead of the low power UART. And this is the green LED. Okay, next we got to go to the NVIC and enable the extension, the external interrupt line 0 and line 15 to 10. Okay, so we'll double check the rest. I2C, SPI, USART 2, okay, so we will generate the code. Let's call this test BLE _1 MTK arm for the KL microvision and generate the code. Yeah, I should okay, doesn't matter for the project name. So first we will configure for the sensor board. So we go to the application user, the main. We have to include the two libraries, the sensor board libraries. Since we are going to extract the temperature data, so we got to put the private variables here for the temperature. And next in the main, we are going to initialize and enable the sensor. So for this case, we are going to use the HTS32, which is the humidity and the temperature sensor, and the function we're going to put in is the environment temperature. So if the initialization is okay, then we have to enable the temperature sensor. So in the while one, in the Bluetooth we can set the name of the Bluetooth that you can see from pairing. So this will be under the sensor.h. Sensor.h. We have to compile one time, the sensor.h will appear. So sensor.h is over here. Double click on this and let's change the name to, instead of a blue, we call it a pink. Okay, the place that to update the temperature, it's at the AppBlue nrg._ms.c. So this file is under the same folder. Double click on this, and if we scroll down to the user application, under process, user process, and over here the values for the temperature and the humidity are actually random numbers. Okay, so instead of random numbers, we are going to put in the values that we sense from the sensor module and pass into the Bluetooth and send it to our application in our mobile phone. But first we got to include the variables that we have declared in the main over here. And once we get the data temperature, we can pass it into our user process. So we have to multiply by 10 so that the values will be in the correct format. So we have to modify the update function slightly so that the temperature will be accurate. We save the file and compile, make sure there's no error. To the project. Under the debug settings, connect with pre-reset. Okay, let's run it. Okay, with me is my mobile phone. You have to download the app called it's called STBLE sensor. You can download from the Google Play Store, or if you're using the Apple, you can also download from the Apple Store. Okay, connect to a device. And you can see the name ping NRG appear. Click on this Okay, and the temperature will be displayed over here. The humidity will be based on the random number. So this is not accurate, but the temperature is what we have called from the sensor module and update in this app. So if I so just let you take a look. If I press on the sensor, so temperature will increase. So my body temperature is around 36 point something degrees centigrade. However, I don't think it can increase until 36. If I release my finger, you can see the temperature now reduced back slowly back to the 30 degrees centigrade, which is the room temperature. Okay, so this is how you can do a simple temperature reading from the sensor board to the application via the Bluetooth extension board. Okay, so that's the end of the video.